Hi, welcome to this tutorial in which I'm going to have a look at negative indices or negative exponents. Now, we've seen already a negative exponent appearing in the last two tutorials, especially the division one. So let's consider something like 2 cubed divided by 2 to the power of 4. Well, if we use the law of indices, and the one in blue on the top right, on this right hand corner, you'll be subtracting the powers, so it will be 3 minus 4, which is negative 1. Now we know what 2 cubed means, it's 2 times 2 times 2. But what we don't know is what this negative 1 power really means. Well, to be able to see that, we'll write the 2 cubed as 2 times 2 times 2. I'll write the 2 to the power of 4 as 2 times 2 times 2 times 2. Now we can see we can cancel those 2's there, and on the numerator we got 1 times 1 times 1, which is 1. In the denominator, 1 times 1 times 1 is 1 times 2 is 2, and don't forget that this power is a 1. So we're saying therefore that 2 to the negative 1 actually means a half, 1 over 2. Well, let's try another example. Let's suppose it's 2 to the power of 3 divided by 2 to the power of 6. Well, if we subtract the powers, we get 2 to the negative 3. But what does it mean? Well, the numerator is 2 times 2 times 2, and the denominator, the 2 to the power of 6, is 2 being multiplied by itself 6 times. Okay? And we can see that those 2's cancel out. And what are we left with? We're left with 1 times 1 times 1, which is 1, and 2 times 2 times 2, which I initially write as 2 cubed. So we're saying 2 to the negative 3 implies it's 1 over 2 cubed. And for example in GCSE it will say write down the value of 2 to the negative 3. Now that's not the answer 1 over 2 cubed, you want to write as 1 over 8, because 2 cubed is 2 times 2 times 2, which is 8. Okay? So what about a cubed divided by a to the 5? Well, it's a to the power of 3 take away 5, which is negative 2. So what would it be? It's 1 over what? A squared. Because a times a times a, that's the numerator. The denominator is a times a times a times a times a. And we can see that these a's will cancel out to leave us 1 at the top, 1 times 1 times 1, and in the denominator 1 times 1 times 1 times a is a squared. So this answer was correct. So we can generalize now and say that a to the negative n can be written as 1 over a to the power of n. And this is really an extension of the division rule. I'd like to show you a slightly different approach. If we take a half, for example, the power of the 2 is a 1, and we know from the zero exponent rule that a to the 0 is 1. So I can replace this 1 by 2 to the power of 0. And if we use the rule of division, we will be subtracting the powers. 0 take away 1 is negative 1. So I've just shown you that 2 to the negative 1 is 1 over 2 to the 1. And if I want to generalize it, I can say a, it's another approach again to the general form, if I wanted a to the, say, minus 3, I want to write as a positive power, I could say it's a to the 0 minus 3. And thinking about the laws of indices in terms of division, I must have subtracted 2 powers to get that 0 minus 3. And that the base is the same, so there'll be an a in each, so there'll be a 0 here and a 3 here to get this negative 3. And of course a to the 0 is 1, and a cubed is a cubed. So a to the negative 3, I've just shown you a slightly different way, is 1 over a cubed. Okay? So let's have a look at some questions, and the first one would be find the value of 5 to the negative 2. Or write down the value of, no calculators allowed. Well, we're expecting to use this rule. A to the negative n is 1 over a to the n. So it'll be 1 over what? 5 squared. And what is 5 squared? 5 times 5 is 25. And that's the answer we expect people to give. Okay? So if we do something like 4 to the negative 3, it's 1 over what? 4 cubed, which is 1 over 4 times 4 is 16 times 4 is 64. What about 10 to the negative 4? It's 1 over 10 to the power of 4, which is 1 over 10 times 10 times 10 times 10 is 10,000. And if I want it as a decimal, what would it be? 0.0001. Okay? What about simplifying, writing them without negative powers? So something like x to the negative 1, y to the negative 2. What would it look like? Well, the x to the negative 1 is 1 over x multiplied by 1 over y squared. And 1 times 1 is 1, x times y squared is xy squared. The reason why we need to write that sometimes is for substitution of numbers for letters. And when you come to do calculus later on, you'd need to go the other way around. So you'd need to be able to write 1 over x squared as x to the negative 2. Okay? So let's have a look at something a bit more involved, something similar to what I did in some of the tutorials, and I said you will be able to see it more clearly. So we're asked to simplify 6a to the power of 4, b to the power of 6, divided by 12, a to the power of 3, b to the power of, let's say, 4, and just a c on its own at the bottom. And if we cancel the 6 and the 12, 6 goes into 6 once, into 12 twice, we get a half in it, and a to the power of 4 divided by a cubed is just a to the power of 1, and b to the power of 6 divided by b to the power of 4 is b squared, and we can see there's a c on its own at the bottom, so I'm just going to write there for now. That's untidy, so write it as ab squared over 2c as a possibility. And I said to you before that it could be written as ab squared c to the negative 1 over 2, and I said I'll show it to you here. Well, let's go back and have a look at this here. We have a half coming in. We have a to the 4 divided by a cubed is a. B to the power of 4 divided by b to the power of 6 divided by b to the power of 4 is b squared. Now I could sneak in a c to the power of 0 here, which is 1. And now I have a c at the top, I have a c at the bottom, subtract the powers, and you get a negative 1. or you can write it as ab squared c to the negative 1 over 2. Okay? Well, I hope you found that useful. On to the next one. Thanks for listening. Take care.